Hi, this is Torin, and welcome to part 2 of the Complete Beginner's CAD tutorial using Autodesk Fusion 360. So this time we're going to be moving on to the next simplest part on the robot, which is the foot. As you can see, there are 3 of these parts, and they consist of a sort of angular base to hold up the weight, as well as an attachment that can attach to the rest of the robot body. In this part of the tutorial, we're going to be learning how to do some more complicated kinds of extrudes, and we're also going to be learning how to use a fillet and a chamfer, 2 features that are very helpful for making parts. So again, let's start from scratch. We're going to want to start with this rectangular base of the foot. So I'm going to create a sketch on the top plane of this part. And this time, instead of a circular sketch, I'm going to use a rectangular sketch. But it's going to be a little bit more useful, instead of using a 2-point rectangle, which is the first one you see, to use the center rectangle. What this lets you do is put the center point right on the center origin of this part, and then specify the height and width of the rectangle. So again, we want all of our sketches to be well defined whenever we can. So I'm going to add sketch dimensions, and we're going to make this rectangle. We're going to make this rectangle a 1/2 inch wide and 3/4 of an inch long. Now we're going to extrude this rectangle to make the body the main weight-bearing part of the foot. So if we were to purely extrude this, we would get a brick-like shape, like a rectangular prism. But instead, we're going to go for a more angular shape. And there are a number of ways to get this angular shape. You don't have to use an extrude, but one good way to do that is to do an extrude with a taper angle, as you see here. So we're going to want to make this, as we have written down, 0.3 inches tall with a taper angle of -15 degrees. So you see what that taper angle did there is it made it more angular. Now a positive taper angle is going to make it angled outwards like that. We want a negative taper angle to angle it inwards as it extrudes. In addition, we also want an extrusion going down, and we could finish this right now and do a whole separate one, but there's an option here that makes it much easier. So under direction, instead of one side, we're going to do 2 sides. And for the second side, we're going to go down by 0.075 inches. And as you can see there, it's now making another part of the foot going downwards. This time, we're going to do a taper angle of -30 degrees. Okay, now that we have the main weight-bearing part, what we need is something that we can use to attach it to the rest of the body. So what we're going to do is we're going to add a sketch up here that extends upwards and has a hole going through it, through which you could, for instance, pass a screw or a dowel rod or something like that. So for this part, we're going to create a new sketch, and this time we're going to want to make it on this sort of right plane that's sort of facing us right now. As you can see, there's still those 3 planes that are right now in the center. And since we centered our sketch on the origin, if we were to, as you move around and you can pick which plane to sketch on, we want to pick this plane here. And as you can see now, we're actually sketching right in the middle of our part, which is where we want to be. So that's good. So what we're going to do now is we're going to place a rectangle. This time we're going to use a 2-point rectangle feature, and I'm going to place my first point and my second point. Great. So now we have a rectangle, but as you can see, first of all, it's poorly defined. I can drag this edge around, which is something I don't want. Second of all, it's floating in space, so if we were to extrude this now, there would be nothing connecting it to the rest of the part. We're going to fix that by telling Autodesk that we want this bottom edge of the rectangle to be in the same sort of in line with this part, with this edge of the part over here. Unfortunately, these happen to be in different planes in space. This edge is ahead of that one, so there are a few different ways to get around that. Number one, we could just draw another line over that one by clicking on line and placing one at each edge of this. But there's another way to do that, which is we can select this edge, then we can go to create, and we can do a projection. So we're going to project that, and then when it's done, we have a projection of that edge in the plane that we're working in. Now, one thing we want to do is this line here isn't actually a part of our sketch that we want to use to create volume. It's just sort of a reference. So in Autodesk, reference geometry like this is referred to as construction geometry. And you can turn this into construction geometry by clicking on it and then going over here under options and clicking the construction button. So it represents construction geometry with a dashed line to let you know that when you go ahead later and extrude or revolve or do whatever you're going to do to the sketch, that's not actually going to get turned into a three-dimensional object. It's just there for your own reference during the sketch. So now that we have that reference line there, we can take this edge, hold down Shift and select the reference line, and we can make them collinear by clicking on the collinear constraint. Now, no matter where we move our rectangle, that bottom line is going to stay adjacent to, that bottom line is going to stay where it is. So in any case, we're going to want to do that same thing again and constrain it with a nice reference line or construction line going right up to the center of the rectangle. That'll give us a reference for where we want to place our circle, which is going to be used as the hole that we can use to screw this part or attach this part onto the rest of the robot. And also it's going to enable us to tell it that we want this rectangle to be centered with respect to the left-right dimension in this plane. So the way we're going to do that is first we're just going to draw a line right up from the origin, which is down here, right up to the top of our rectangle. And we want it to be a straight line. Again, if your line didn't come out straight, you can click on it and click on this horizontal vertical button to make sure it's vertical. Now we want to tell it that this line is supposed to go intersect with the middle of this rectangle. So we're going to select the edge of the line and then hold down Shift and click on the rectangle that we're sketching in. And we're going to click this here constraint, the triangle, which means midpoint. Now, as you can see, the rectangle is centered in the middle of our foot, which is great. So finally what we're going to do is we're going to create our circle, and we're going to put that circle on this line, like so. And now I could have done this before I created the circle or afterwards, but it's important we do it at some point, which is we select this line and specify that we want it to be construction, which again, you click on the line, click construction, it'll turn it into a dashed line so that we're no longer bisecting this rectangle with a real line. It's only a dashed construction geometry. So now we're almost there. We just have to set some of our dimensions so that our width and height and position of this circle are all well defined. So we're going to make this circle 0.17 inches in diameter. We're going to make the width of the rectangle 0.35 inches wide. And then what we're going to do is we're going to, so far we've been using the dimension tool to just change radii and widths, but you can also click on 2 points to define the distance between them. So we want the center of the circle to be 0.25 inches or 1/4 inch from the surface of the foot. So I'm going to click on the circle, I'm going to click on our construction line down here, and now it's going to create a dimension to say how high off of that we're gonna make that circle. And there we go. And lastly, we're going to define the distance between the center of the circle and the top of this rectangle. And before they do that, we're going to want to make sure that we've dragged this up so that it's above the center of the circle. And then what we're going to do is we're going to define a dimension going from this, which was already selected, to the center point of the circle. And we're going to define that as 0.15 inches. And there we go. Everything is well defined. Everything is a black line. So we can finish our sketch. All right. So now we're going to extrude this. And we're going to do that by clicking on extrude, click on our sketch. And this time again, we want to go in both directions. But we want to go the same amount in both directions. So under direction, we're going to do symmetric. And you'll notice what this does is when I add volume, it adds it in both directions. We want the width of the full part to be 0.175 inches. So we're gonna set the measurement to whole length, and we're gonna set that distance to 0.175 inches. There we go. So now we have most of the features on this thing, on this foot done. There are just a few small things that we're going to do to finalize it. The first thing we're going to do is we're going to add a fillet. A fillet is something that'll take a corner of your part and make it round, as you can see in this picture. Now, a fillet is important in the purposes of engineering, not just because in some cases it might make it look, have a different look to it, but in addition, when you have parts like this extruding upwards, and then and if you expect any sort of force to be applied to them, adding a fillet makes it less likely that this part is just going to snap off the rest of the foot, because it distributes the forces in a way when that force is applied to the top edge of it. So for our purposes, it might not be fully necessary for this small robot, but in general, it's often good practice to include fillets in cases like this where you might be worried about something snapping off. So what I'm going to do is I'm going to click fillet, and I'm going to click on the edges that I want to become rounded. So I want all 4 of these edges to be rounded. And then over here I'm going to specify the radius that I want. And in this case I want a radius of 0.05 inches. And as you can see, we have our nice rounded feature there. And as you can see, we have our nice rounded feature there. And so the last thing we want to do for this part is to add something called a chamfer to the top edges over here. A chamfer is similar to a fillet, but instead of rounding, it just cuts at an angle that you can specify, but by default it's a 45-degree angle. And in this case, we're just adding this chamfer so that it's easier to allow the feet to rotate around without this corner getting in the way of the smooth rotation. So I'm going to click on both of these edges where I want to chamfer, and again you can specify the distance, and in our case we want 0.1 inches, and that's going to create our chamfer. So that's it for creating a foot of a robot. So just to go over as a recap, in this video we learned how to do some more complicated sketches involving more features in relation to one another, involving construction geometry, and then we learned to do some more interesting extrudes, such as extrusions in 2 dimensions and extrusions with a taper angle. Finally, we learned how to modify features of our part using fillet and chamfer for uses such as getting some material out of the way so it might be easier to rotate, and also for the purpose of protecting our parts from breakage. Next time we're going to do the arm, which is a part that involves more complicated, more intricate relationships between the volumes and the sketches. So whenever you're ready, you can move on to that next video.